Okay, so here we are at our first introduction to trigonometry. And before we can do anything in trig, we need to talk about angles and how we're going to talk about them and represent them and what they mean in trig. Because it's a little bit different than what you experienced in geometry. So here we go. Angles, instead of just thinking of it as an angle hanging out in space or in a plane or something, we actually think about angles as being a rotation of a ray about a point. So in this example here that I have angle AOB, you can see this ray OB could have been thought of as starting at the initial side of OA and rotating around until it stopped at this location. And what was created was an angle. So it's kind of like starting from here, it rotated around until it got here. Draw my little funky arrow there. And so you get this angle that's created, and it's an obtuse angle. The thing is that who's to say that I went in this direction, and maybe I went in the other direction? So there's another angle that you can consider over here on the big side. We'll talk about that later, but what you need to understand here from the vocabulary standpoint is that the initial side is where your ray starts, and your terminal side is where your ray ends. Okay? So there, like I said, there's two different directions that you could have rotated your ray. You could rotate it in the counterclockwise direction, which you saw I did right here. So that's going around in this direction, that's counterclockwise. Or you could go in the clockwise direction, so that's starting here and going around in that direction. So when you look at these angles, you know, these two look like they're congruent, those two look like they're congruent. But depending on the rotation that they took, they're going to actually be different sized angles. So in a counterclockwise direction, which I'm going to abbreviate with the CCW, that's the positive direction. So when you look at these two angles, right here, this is a positive angle right there. So I rotated into the counterclockwise direction. Over here, this is also going to be a positive angle, but it's going to be way more than 180 degrees. So I go all the way around until I get there. Okay, so you can have positive angles, and you can have angles that are larger than 180 degrees. And likewise, we can have negative angles, and we can have negative angles that are less than negative 180 degrees. And so going into the clockwise direction, which I abbreviate with the CW, that's going to give you a negative angle. So for example, over here, where this angle looked identical to this one above, going in the clockwise direction, now I go like this, and I get a much bigger, or I guess a much smaller angle because it'll be negative. Whereas this one over here, I'm going in the negative direction. I'm starting at my initial side here, going into the clockwise direction. That's the angle that I get. Very different than the one that you have up there. Okay, so we need to really be aware of this positive versus negative movement, clockwise versus counterclockwise. Okay, moving on. Okay, so the measure of an angle is going to be given in rotations and in degrees. For example here, if we look at these three examples, I have one rotation in the counterclockwise direction. That gives me 360 degrees. So think about it like this. I'm going in the counterclockwise. So I start here at my initial side, go all the way around, and I end up where I started. So I've gone a complete 360 degrees going around. For this one, half of a rotation in the counterclockwise direction gives me 180 degrees. That's our straight angle. So I start here at my initial side, and I go halfway around, and I stop right there. That gives me my straight angle. And I went in the counterclockwise direction. If I had gone in the clockwise direction, I would have gotten a negative 180 degrees, right? And then over here, this angle looks exactly like that angle, but notice in this case I'm going one rotation in the clockwise direction. So this one I'm starting here, going around in this direction, and you get that. Okay, so you're gonna have problems where they give you how many rotations or fractions of rotations in certain directions, and then you have to calculate what is the actual measure of that angle in degrees. Okay, so here we go. For the given rotation, find the measure of the angle in degrees, and you're going to sketch the angle. So first of all, let's not worry about sketching it just yet. Let's talk about the 1/8 of a rotation in the counterclockwise direction. How are we going to set up this problem? Well, first of all, we know we're going to take 1/8 of something. And since we are rotating in the counterclockwise direction, that means we're going positive. So the positive direction would be a positive 360 degrees. So we're going 1/8 of 360 degrees, which is going to give you 45 degrees. So there's the measure of the angle. Now what you're going to have to do is sketch it. So when you sketch it, you do need to draw a little x and y axis. This does not need to be on graph paper, but we're still going to have an x and y axis. It doesn't have to be large. You don't have to label anything. And what you're going to do is you're going to draw in a ray where you feel this angle is. So 45 degrees, that's somewhere over here, like halfway, right? So I'm going to draw in a ray like that. And then what you're going to do is you're also going to draw in the curved arrow that I've been drawing all along to show me the direction that you're moving to get to that ray. So we started here and we're moving in the counterclockwise direction. I moved up to there and I stopped. So if you don't remember this arrow, it's not going to be correct because I'm not going to know what direction you moved. Okay, so that is how you would do that problem. Let's try this one. 3/10 of a rotation in the clockwise direction. So clockwise is negative. So I'm going to do 3/10 of a negative 360 degrees. And when I work that out, I get a negative 108 degrees. So to sketch this angle, now we have to really think about this because it's a negative angle. We're moving in the clockwise direction. So we start right here at our positive x-axis. And if I'm moving around in the negative degrees, this is a negative 90. This would be a negative 180. So negative 108 is going to be somewhere in this quadrant down here. So I'm going to go ahead and draw my ray. And notice that you don't have to, oh, that was terrible. Try again. Okay, you do not need to use a protractor or anything to measure this out exactly. You just kind of eyeball it, and that is once again a terrible straight line, but you get the point, right? Good. Okay, so drawing my curves to show me I'm going in this direction. Apparently I do curves a lot better than straight lines. Can't do that. Okay, so there's how you would do that problem. Okay. Let's see what's next. Okay, so I've kind of been dancing around this issue of standard position. An angle whose vertex is at the origin and whose initial side is the positive x-axis is an angle that's considered to be in standard position. We are pretty much always going to be talking about angles in standard position. I can't really think of an example where we're talking about angles not in standard position, other than when we start talking about right triangles as a part of a situational, problem. I don't know. Don't worry about it. Everything's going to be in standard position, okay? So when you are working with your angles, always know that the initial side will be the positive x-axis. All right, so the next thing we have to talk about is quadrants. And I think you remember this. Your x and y axis here break up the Cartesian coordinate plane into 4 quadrants. And you should know that the first one is the positive quadrant, so when x is positive and y is positive. Then you move, once again, in the counterclockwise direction. That's the standard kind of way of moving around. So we get the second quadrant over here, third quadrant down below, fourth quadrant over there. Please note that I have written these in Roman numerals. I know you guys don't use Roman numerals very often anymore, but this is the one place where we will. So please don't write quadrant 1, 2, 3, and 4 in the standard notation. It should be in Roman numerals. Okay, so they're going to ask you what quadrant does an angle lie in? And so what they're talking about is which quadrant is your terminal side of your angle going to fall into. So if you had a ray that was down here, like this, then you would say that this angle landed in the third quadrant. Okay? So what happens if your ray lands on the axes? So maybe it landed right here on the positive x-axis. Well, we're going to call that a quadrantal angle. So it doesn't lie in any one of the quadrants, but it does lie on one of the axes. It's called a quadrantal angle. All right, so we can have angles that are in standard position whose terminal sides coincide, which means they lie on top of each other, or they share the same side. And those are called coterminal angles. So for example, what I've drawn here, I have this ray, and you look at this ray, probably thinking maybe this angle is a 45-degree angle, which, sure, that could be correct. I have an angle right here starting in the standard position. There's a 45-degree angle. But who's to say that I didn't go around in the other direction? Maybe I went in this direction and I landed here. That's going to give me another degree. So this is a positive 45 degrees, but this is going to be a negative 315 degrees. So those have different measures and they had different directions, but they both shared the same ray. So those two angles are considered to be coterminal. Now what's interesting is that you can actually spin around as many times as you want. Let me get rid of that. So look at this. What I could do is I can start here, say I'll go in the positive direction. I can spin around, you get this nice big spiral, and then I can stop here. So I've gone around one rotation, that's 360 degrees. I go around another rotation, which is another 360 degrees. Now I'm at 720 degrees. And then I go an additional 45 degrees. So we can have angles that are larger than 360, which is kind of interesting to think about. Okay? So when we want to represent an angle, the typical Greek letter that we're going to use is the letter theta, which looks like an O with a line going through it, and it doesn't go at an angle, it goes straight across. Okay, so you need to get used to writing the theta symbol for our angles and understanding when they use it, what they're talking about. Okay, so here's another example. It says, given theta is 135 degrees, and you're going to go 2 clockwise rotations. What is the measure of the coterminal angle? So we want to know the other measure, if instead of just going positive 135 degrees, instead we're going to go 2 counterclockwise rotations and then the positive 135 degrees. What's our new angle? Because the ray is going to land at the exact same spot. Okay, so algebraically, how are we going to set this up? Well, here's the formula. What you're going to do is you're going to start off by talking about your rotations. So how many did we have and in what direction? So we had 2 rotations in the clockwise, so that means the negative direction, so a negative 360 degrees. After you figure that out, then you're going to add on the angle that you want it to be coterminal to. So we want it to be coterminal to 135 degrees. So we just add 135 degrees to it. When you work out all the algebra, then you get negative 585 degrees. Okay, now it doesn't ask us to graph this, and I'm not going to worry about it, but if you're interested in seeing what that graph would look like, ask me later in class. Okay, next one. Given that theta is negative 45 degrees, and we're doing 1 counterclockwise rotation, find the measure of the coterminal angle. So once again, we're going to set it up just like we did over here, where we talk about the number of rotations and the direction that we're going. So we have 1 rotation in the counterclockwise direction, so that's a positive 360. And then we're adding our angle, and our angle happens to be a negative angle. So we're adding a negative, which if you want, you can just say you're subtracting it, but I know that confuses some people sometimes. So the standard form is to add the angle. Okay, so when we work this out, we get 315 degrees. So that means 315 and negative 45 degrees are coterminal, just like negative 585 degrees and 135 degrees are coterminal. All right, that was a lot of introductory information. Hopefully you can absorb it and it'll be okay. These problems they should be fairly simple until you get the hang of it, and then we'll be able to move on. Okay, good luck.